Now let's quickly write the Python logic for finding the square root of a number using binary searching technique that we have discussed. So here, I have created new file and, added the class and added the function declaration and added the code for calling that function as well. So here, let me just, get started with the implementation. Since we are going to use binary searching technique, I'm going to initialize start and end. Start will be starting from 0, end will be whatever the number that we are getting itself. Along with that, I will also define middle, and I'm going to initialize it with -1. And we need to calculate the middle, right? To calculate the middle, we need to floor it. That's why I'm also writing the import of math as well. Now I will simply run a loop as long as the start is less than or equal to end that we have. In this case, what we will do, we will simply calculate the middle. Middle is nothing but math.floor of start plus end divided by 2. Once we have this middle, what we will do, we will calculate the square of the middle. That means middle multiplied by middle, if it is equal to the number that we have got, in that case the actual squared value of this middle is equal to the number. That means the square root of the number is nothing but this middle itself. So here we will simply return middle itself. Okay, if this is not the case, the other scenarios are basically the squared value of this middle could be greater than this number, or the squared value of this middle could be less than whatever the number that we have got. So in those scenarios, if the squared value of this middle is greater than the number that we have got, in this case what we need to do, we need to search for the square root till the values middle -1. To continue that, what we will do, we will update end with middle -1. Okay, and obviously the other scenario is squared value of this middle is less than the number. In that case, we need to search the actual square root from the value middle plus 1. So we will update start with middle plus 1. Okay, now that is what the entire logic is all about. But there is one scenario, right? If at all the number that I am passing does not have a whole number which is a square root. Let's just say the input that I am passing is 4. 4 has a square root of 2, right? So the output will be returning 2 here. But what if the input that I am passing is 8? 8 does not have a proper square root number, right, which is an integer. To calculate and return the closest number for such sort of numbers, let's just say 8. 8 has square root of 2.8 something similar to close to that. So in that case, we need to return 2. To return the square root for such type of numbers which does not have actual square root, here we will simply be returning the start -1. Okay, once we complete this value, whatever the value we have inside this start will be having one value greater than the closest square root integer, because here in each and every step we are incrementing it by 1. I mean incrementing it by middle plus 1. So in the end, whatever the value we have inside the start, -1 will give the closest square root for that particular number, if at all it does not have the whole number as square root. Okay, so that is the logic for finding the square root using the binary searching. Now let's just get started of testing this logic using numbers which have proper square root. So if I run this code right now, the input that I'm passing is 9. 9 has a square root of 3, right? So if I run this code right now, 3 is what we have got. Let's just say I'm passing 25. So 25 is nothing but 5 square. So the output is 5. And let's just say the input that I'm passing is something like 28. 28 does not have a square root which is whole number, right? In this case, the square root will be something like 5 point some number, but the closest integer is 5, so we will return 5 output here as well. So that is what we have got. Let's just say I'm passing 30. Okay, 30 also does not have a whole number which is square root, so here also we will get same 5. Any value till 36 we will be getting 5 only, because till 36 the closest integer for square root is 5. As soon as we pass 36, 6 square is 36, so the output should be 6. That is what we have got. And one more thing that you need to observe here, I am testing only positive integers because the problem statement clearly mentioned that we will not be passing any of the negative values. If at all, if your problem statement doesn't mention that, there is a chance that you could get negative numbers also, you can simply add a check here. If at all the number that you're getting is less than 0, you will not have any square root for the negative numbers. In that case, you will simply need to decide what value you can return in that specific condition if at all the number that you're passing is negative, based on the discussion that you can have with your interviewer. Anyway, I will not be writing that logic, but it is completely up to you. Anyway, that is the effective way of finding the square root of a number using binary searching technique. If at all, if you want to check out the brute force solution also, you can use the link in the description to go to codingpal.org and find the solution using all the various other approaches. Okay, anyway, that's it for this one. I'll see you in the next problem.